All right, moving on to lesson 4.2. We are working on adding and subtracting polynomials. Polynomials are all different kinds of terms that are added and subtracted. Our essential question, can you add and subtract polynomials, which is just combining like terms? Let's talk about the different types of polynomials that we know of. We're going to start with a monomial. A monomial has one term. 4ab, all multiplied is one term. Negative 6x is one term. 7 is called a constant. There is no variable, so we just call it a constant. Let's look at like negative 7x squared y to the 5th z to the 8th. This is also a monomial. There is only one term. So make sure you know the difference between a monomial, and now we're going to look at what we call a binomial. A binomial has two terms. Notice that 2x plus negative 9 or minus 9 is two terms. 2ab plus b squared is a binomial, two terms. A trinomial has three terms. X squared minus 4x minus 5, a squared plus 3ab minus 4b. Oh, that is b squared, I was checking. Okay, this is called a trinomial. Anything with multiple terms, 3 or 4 or more, is called a polynomial. All right, so in monomial, negative 3xy squared, notice that we call negative 3 the coefficient. This is called the coefficient. I keep thinking that I'm highlighting. So the next thing we have to decide is which ones have like terms. So notice I have an x squared here, and I don't think there's just an x squared anywhere else. Well, that one's all alone. What about a xy squared? Is there another xy squared? And another xy squared. So notice all of these in yellow are like terms. And 16xy looks like it's standing alone. And remember that we can simplify these by adding and subtracting like terms. So the only like terms here are the one in yellow, negative 5xy squared, xy squared, and 1/3 xy squared. So we're going to start off by adding like terms. So let's go ahead and look at example 1. Notice I have a negative 3x squared and an x squared. Notice the sign goes with the term. I actually think I'm going to highlight. I like it better. And then I have a positive 5x and a negative 2x. And notice this negative 4 stands alone. So when I add these, negative 3x squared and positive 3x squared is negative 2x squared. And 5x and negative 2x is 3x. And the negative 4 is going to stand alone. Let's look at the next one. I have different things here. I have a 4m squared. Ooh, and I have a negative m squared. And then I have a 5mn squared and a 3mn squared. So when I add these together, in this case I'm subtracting, I have 3m squared. And when I add these, I get 8mn squared. And the last one that we're going to look at, notice I have a negative 6x cubed and a positive 6x cubed. We'll talk about that in a second. A positive 3x squared and another positive x squared. And a negative 5. When I add these together, notice the negative and the positive, those are opposites, those will cancel out. 3 and 1 is 4x squared. And the constant, negative 5, stands alone. Let's just review. This is called a trinomial because it has 1, 2, 3 terms. This is a binomial. It has 2 terms. And we have another binomial with 2 terms. All right, moving on. This one's getting a little bit more confusing. Write the sum of the areas of the rectangles in simplest form. Well, the first thing I have to understand is how do I find area? I know the area of this yellow A is going to be base times height, or length times width. When I multiply these, I get 10, and I have 1 and 2 x's, so that's going to be x squared. All right, let's look at the next one. I know the area in the pink is 5 times 5x. When I multiply these, well, first of all, we're finding the sum, so I know I'm going to add all these and multiply these together. 5 times 5x is 25x. Moving on to the next one, C. I have to multiply 2x and 2x. We're finding the sum. When I multiply 2x and 2x, I get 4x squared because this is 1x and 1x. And then my last one, to find D, I'm going to multiply 5 by 2x, and I get 10x. Well, we can add like terms. Notice that 25x and 10x can be added. Also, 10x squared and 4x squared can be added. So my final sum for the area is 14x squared plus 35x. All right, the next thing we're going to discuss is the degree. If I look at example 5, notice I have a monomial. There's just one, no adding or subtracting in between. But I also know that this has a degree of 3. The y has a degree of 1. The z has a degree of 2. To find the degree of everything, I'm going to add those. 3, 1, and 2. And I know the degree of this monomial is 6. Looking at our next one, I have an x squared y. Again, that is going to be y to the first, and z to the fourth. So I have to take 2 plus 1 plus 4. The degree of this one is 7. All right, the last thing I'm going to go over, sometimes you guys get confused on how it's worded. So it says subtract 2x squared minus y squared from this trinomial, 5x squared plus 7xy plus 2y squared. So remember, I'm taking the trinomial and I'm subtracting all of this binomial. So what do you suppose I have to do with this negative right here? Good. I have to distribute it to here and to here. I'm going to take the time to rewrite everything. So I have a minus 2x squared and a plus y squared. And now I want to look at like terms. I have some x squares. I don't have another xy, but I do have another y squared. So when I add this all up, 5x squared minus 2x squared is 3x squared. And the 7xy is going to be alone. And the 2y squared and the y squared add up to be 3y squared.